In this question from the chapter sequence and series based on geometric progression, it says let S be the sum, P be the product, and R be the sum of reciprocals of n terms of a GP. We need to prove here that P raised to the power 2, R raised to the power n is equal to S raised to the power n. So what we'll do, let's say if I take the AP as AR, sorry, not AP, GP, AR square, AR raised to the power 3 and so on up to AR raised to the power n minus 1. As you know, the nth term of an GP is this. So in the first case, we have to obtain the product. So let's say if I say product, first I'll obtain P and then we'll obtain what is P square. So what is P? P will be the product of that is A multiplied by AR multiplied by AR square dot AR raised to the power 3 and up to AR raised to the power n minus 1. Now, what you can do here that if you see the A only, look into just A. So A is multiplied how many times? This is something that you need to focus here, that A is multiplied by, just look into A. So we'll say that in this case, A is multiplied by n number of times, right? So one can get confused with n minus 1, but then you see that A starting from here and ending till here. So we'll say A being multiplied n number of times means what? A raised to the power n. And now for the R you figure out. This is R raised to the power 1 into R raised to the power 2 into R raised to the power 3, so on, up to R raised to the power n minus 1. Now for this part, what we are going to do is, you can see here that when same bases are multiplied, powers are added. By applying the laws of exponents, going to be 1 plus 2 plus 3, so on up to n. Now this is what sum of first n natural number. This is up to n minus 1. What is the formula for the sum of first n natural number? So if you see, I'll write it here if you do not remember. The sum of first n natural number is what? N into n plus 1 divided by 2. So check here, this is n, which is this, right? N, I'll show you properly. Well, n for us is this, right? N minus 1 is n. So it's going to be what? N. And then I'm writing n plus 1. So this is n and plus 1. N plus 1 divided by 2. This divided by 2. So you can figure out that these get cancelled, like minus 1 and 1 get cancelled. So we get finally P as what? P as A raised to the power n, R raised to the power, this is n. I'll write this first, multiplied by n minus 1 whole divided by 2. But you can figure out from the question that we actually need to get P square. So I'll find the square of this. Now you need to be focused here that if I P square, then we are going to find the square of this. So that means, let me show you. If I say AB raised to the power 2 is what? A square B square. So it's going to be square over both the numbers. So that means square of this is what? I mean square of this is A raised to the power 2n. Now this is very important. If I find the square of this, right? So we are actually going to multiply 2. Or you may say like this. We have to place a square of this. So this 2 will interact with this 2 and get cancelled. Right? One more time. This is R raised to the power n, n minus 1 over 2. If I have to find the square of this, it should be like this. And these are powers only. 2 and half are powers, so they get cancelled. So we'll say that this is going to be R raised to the power n into n minus 1 as this 2 get cancelled. Now what we got? We got the first, that is R's P square we got. Now in the next part, I'm going to find R raised to the power n. And sorry, before that, you should know that R is the sum of the reciprocals. So this time A is 1 over A, right? We are getting the reciprocal and we are also getting the sum. So I'm adding the reciprocals of each term and so on. That is 1 over A raised to the power R minus 1. Now for this, I'm going to apply this Sn formula as a 1 minus r raised to the power n over 1 minus r. And this is because here r is less than 1. Let's see if I apply this formula over here. So what we are getting r as, this is sum of their reciprocal a, which is 1 by a here. So I wrote 1 by a bracket 1 minus r, which is 1 by r. So you can divide this by this. You'll find here the common ratio is 1 by r. So 1 by r raised to the power n, right, because of this n, and that whole divided by 1 minus r. Well, r is what? 1 by r. Now we can simplify it further. Let this be 1 by a. If I take LCM over here, it's going to be r raised to the power n minus 1 over r raised to the power n. And this side, what we are getting? We are getting r minus 1 over r. So we are getting r minus 1 over r. So let me show you first. This is what we are getting. So we know that dividing is same as multiplying with the reciprocal. So we can shorten the working by writing r over r minus 1. Now further we can do one more step of simplification. This is r raised to the power n minus 1 over. These two are like terms. Well, what I mean to say that I'm going to apply the laws of exponent in these two. So you see, this can be written as what? Same basis multiply, power subtracted. So r raised to the power n minus 1. Right? This is 1 is in power, and that whole divided by 1 over r minus 1. Once we have get this, now next is what? To obtain r raised to the power n. So getting r raised to the power n means what? We are going to place n power. So this is now r raised to the power n is what? Wherever with every term I'm going to place n power. So this is n over this. Likewise, this is r raised to the power n minus 1 over r raised to the power. If I write it separately, is going to be what? R raised to the power n minus 1 raised to the power n for this power. And this is r. Placing an n power over here is what? N into n minus 1. And that multiplied by 1 over r minus 1. And that over power n. So let me figure out once again that wherever I'm placing this n power is because it is r raised to the power n. So wherever I place that yellow ink n is for this r raised to the power n. Now once we have obtained this also, what we have to do is to get s raised to the power n, where s is what? Where s is, s be the sum. So it's a normal sum. So we'll say that Sn is what here? Sn is a r raised to the power n minus 1 over r minus 1. And yeah, that's what. And then we have to get s raised to the power n. Well, Sn is s here, right? So s raised to the power n, right? This is not Sn. So Sn will be what? Everywhere you will place an n power. So a raised to the power n. Similarly, r raised to the power n minus 1 whole power n, right? And then r minus 1 raised to the power whole power n. Now we have to prove this. We have RHS in the simplified form. Let's deal with the LHS. Now what is LHS? LHS, as you can see, it is product of these two equations. So let's say if I do this here, this is what? LHS, which is p square r raised to the power n. P square is this. So I should write this as a raised to the power 2n into r raised to the power n multiplied by n minus 1. I'm simply copying from here. And this multiplied by, I need to accommodate it here. So I'll not write this. This is understood. I'll make space for, yeah, this is by RHS. We are doing this as RHS. Oh, that's LHS. It's not LHS. LHS. And this multiplied by this thing, which is what? 1 over a raised to the power n and r raised to the power n minus 1 whole power n, and that divided by r raised to the power n into n minus 1 into 1 over r raised to the power r minus 1 raised to the power n. All right. So things which get cancelled here are what? I can see this get completely cancelled. And using these, you can observe that from this and this term, we can apply laws of exponent. And so it's going to be what? Same basis divided, power subtracted. Then we are left with r raised to the power n minus 1 raised to the power n from here over r minus 1 raised to the power n. Now check. This is same as this. This is the RHS, right? This is our RHS and this is our LHS. So we got LHS is equal to RHS, a raised to the power n bracket r raised to the power n minus 1 whole raised to the power n over r minus 1 raised to the power n. This is how we'll do this question.